Welcome everybody, and thank you very much for coming to my presentation. And as you can see by the title of the presentation, we are going to touch the database access layer. Since this is a Java related conference, then we are going to talk about JPA. And well, probably many of you have already used some JPA in some form, either just directly by using JPA, Hibernate in particular, or maybe some higher level abstractions like Spring Data JPA. And I think we can all agree that they are very easy to use. They are easier definitely than using, say, JDBC or any lower level libraries. But very often we need to maybe not often, but sometimes it happens that we need to pay a high price when it comes to performance for this comfort. And this is what the presentation will be about. So I really hope that you will learn something new, that it will be of some use to you. Before we jump in, a few words about me. My name is Jędrzej Biedrzycki. I'm a senior developer at CERN. I also write a blog where I post semi-regularly on all the topics that I find interesting related to Java, Scala, SQL, well, mainly backend related technologies and topics. So if you are interested in learning more about that, please feel free to check it out. Also, feel free to ask any questions regarding presentation, regarding the examples that I'm presenting to you, or anything that has something to do with the JPA, with Hibernate, with performance and database access layer. I will be really glad to try to answer those questions. There will be the time dedicated for questions at the end of the presentation. So to make our discussion concrete, let's imagine that we're going to build an application, a web application for a bookstore. So we're going to need a basic data model, right? Obviously, we're going to need a book entity with some title and some reviews, and the review entity with the grade and the review comment, which references back the book, so the parent. As we can see, both are entities. As we can also see, they both extend abstract entity. And this abstract entity is just an abstract class with an ID field. You probably know that to define an entity in JPA, you need to provide an ID, a field that will be an ID of this entity. So to avoid redundancy, I simply extracted it into a separate superclass. And maybe a few words relating this mapping. We have a classic bidirectional mapping. We can see that the child side owns the relationship, which means it has all the configuration with this join column, and also this column book ID will be added in the review table to synchronize this reference between those two entities. Then we will also have awards. A book can have multiple awards. An award will have a name and some details, the year it was awarded. And as you can see, here it is slightly different because I'm using embeddable to model this award. And on the parent side, on the book side, I'm linking this award to the book table with element collection and the collection table. So here I'm defining a table that will store the awards with the join column. So the procedure is similar, it's just the configuration is slightly different. Also, a word, as I have mentioned, is an embeddable, so it is not an entity. It does not extend this abstract entity. And last but not least, we are going to support messaging in our system. So we'll have a message with a title and some content, the IDs of server and the receiver, and the flag whether the message was read or not. This is also an entity with an ID. And let's jump into the first problem. Maybe just a small note before we begin. If it's more comfortable for you to ask questions in Polish, you can also do so. I will try to translate them. This is not a problem for me. So feel free to ask in any form you like. Let's imagine this scenario. We would like to display all the reviews for some books, given the IDs of those books, right? So this signature tells everything. We would like to display the reviews by book IDs, and we are given a list of IDs. And here's one example how we can implement this. So from the book repository, we can find all the books by IDs. And then for every book, we are getting the reviews, streaming them, and then flattening the stream. And then for each review, we are displaying it. And it doesn't really matter how this display method is implemented. It can simply print it to the console. It can push it to the front end. The thing to remember is that it only displays the review. So it just consumes the review, uses the information from the review, and does something with it. So everything looks nice, right? And if we try to test this method, so if we run our application or run a test on it, then we can encounter this. So the infamous lazy initialization exception. What we can see here is that it failed to initialize a collection, could not initialize proxy, no session. What does it even mean? Maybe you have attended the presentation, a very nice presentation by Łukasz Pięta, which was given a couple of hours ago. It was very interesting. If you missed it, then I highly recommend going back to the recording and watch it. Łukasz has introduced some things that I'm going to touch here, but happily it will not overlap that much. But one of the things that he has mentioned is that if we take a look at our mapping again, the standard in JPA is that every 2-1 relationships, so every many to one and every 1-to-1 is fetched eagerly, and every too many, so 1-to-many and many-to-many, is fetched lazily. What it means is that if I fetch an instance of a type review, then I will get the book for free. Well, not for free, but it will be populated with the data. Once I get the review, I will have also the book by default. Whereas if I fetch an instance of the type book, then Hibernate will not fetch the data related to reviews. Instead, it will create a proxy over this field. And then if we try to interact with this proxy somehow, if we try to access this field, then it will complain. It will try to populate it with the data, but if it cannot, it will complain with the exception that we have seen here, right? So this is exactly what happens in our example, right? In our scenario, we're fetching the books, and by using this find all by ID, we're opening the session to the database, we're fetching the books. Hibernate creates a proxy over the reviews, and the session is closed, right? And now when we try to interact with the reviews, it says the session is closed. I cannot access the data, so it throws an exception. And what could be, what can we do to solve this problem? What could be the solution here? One of the things that might come to your mind is that, okay, the session is closed. What if we make this session not close before we are done with our job, right? So for example, we can open a single transaction and then within this transaction do everything so that Hibernate can populate it with the data. And indeed, if you try to Google it, if you search around, you may encounter, unfortunately, heavily upvoted answer on Stack Overflow that if you just use transactional, then it will work. It will work, well, yes, but actually no, it will work in that sense that no exception is thrown and the application works. But probably what Hibernate is doing under the hood is not what you would expect from him. To investigate what Hibernate does, we can use either this line in our application properties. If we write a Spring Boot application like I did here, or the following line in Hibernate config if you're using Hibernate directly. And then we can see the logs, what Hibernate is throwing at the database, right? Let's examine what we have here. First, we have select from reviews. And this is kind of intuitive, right? So I told you, okay, we have the books, and then Hibernate needs to repopulate those books, those reviews, because they are not fetched by default, right? They're lazily fetched. So once we interact with them here, Hibernate needs to go to the database again and just fetch them. But then something weird happens. We have a bunch of selects. All of them look the same, right? This is the same select, but it's run multiple times. So what is happening? Let's come back here for a moment again. I have already told you that every too many is fetched lazily, which we saw by this lazy initialization exception, but every too one is fetched eagerly, right? So in this next step that Hibernate does in repopulating the reviews, it also needs to populate this book field for every review that it is fetching, right? So it fetches a bunch of reviews, but it doesn't know to which books each of those reviews it cannot associate the parent with the child in this next step, right? So it needs to go to the database again to fill this book with the data. And that's what we see here. That's what he does. He just goes to the database for every review and fetches the book to populate it with the data. And hence the name of the problem, right? We have one query to fetch all the children, and then for each child, we issue another query to the database to fetch the parents. So if there are n children, there are n+1 queries run in total. So that's where the name comes from. So we can see that it kind of worked, but the load that we are putting on the database is rather large, right? We do not have many entities here. If there were more of them, it would be even more apparent. So that's not really the way to go. What we need to remember is that transactional, by definition, by the name, it needs to be used on the method that is that needs to be done atomically, right? Either all the steps are all executed or none of them is, right? This is the idea behind the transactional. So it shouldn't be really used just to mitigate the imperfections in our modeling of the data. Let's think of another solution to this problem. What else could we do? Well, this lazy loading is, it kind of gets in the way, right? Because we wouldn't get this lazy initialization exception if the reviews were fetched already, right? So if we change this fetch type to eager, then it does work, and it indeed issues a single query to the database, right? We do not need this transactional anymore. We just say to JPA, to Spring Data JPA, get all the books, and it gives me all the books together with the reviews. So it did solve our problem. But let's now imagine the following. We're developing our application, so it grows, it evolves. Our data model becomes larger and larger, and we have the following hierarchy in our project, right? And at some point, we would like to fetch a single instance of the type A. Now, what would happen if everything was fetched eagerly? Together with this single instance of type A, we would also fetch all the children of type B and of type C. What is more, that would cascade further to fetch for every child of type C also the children of type D and E. So as you can see, we only needed a single row from the database, but instead we're fetching half of the database into the memory of our application, just because we're not telling Hibernate exactly what we need for the job at hand. So this is also not the a good way to go. We can be more explicit in what we're doing, right? So this eager fetching worked in our scenario. It's just we do not need to always fetch it eagerly. So we need to tell Hibernate, okay, fetch the books together with the reviews. And this is what we're doing here. This is yet another solution. This time I'm using Entity Manager. And by the way, I'm just mixing different implementations so that you can see different possible solutions. It's not that it is only, this one is only done by Entity Manager and JPQL. It could very well be done with the Spring Data JPA, or using native SQL. So everything works. It's just I wanted to show the diversity of of solutions. And let's take a look at what we have here. I have written a simple JPQL query, select B from book, so select all the books, left join fetch reviews. So together with the reviews, with this fetch keyword, I'm instructing Hibernate to also populate reviews with the data. So what I will get here is all the books with the reviews field populated, right? So we're leaving it lazy as it was by default. And now we're just telling at runtime, fetch all the books together with the reviews. For brevity, I have omitted here the where clause, but yeah, you get the idea. It doesn't really change anything in our discussion. And now if we take a look at the logs, at what Hibernate does, we can see a single select. So this is quite an improvement. We had a single select earlier where we fetched everything eagerly, but here we're not compromising the future performance of the application. Everything is fetched lazily. But here we're just telling Hibernate that we're going to need some more data for this use case. Yes, so this is quite an improvement, but now I would like you to consider one thing. What would you do if you were to write just a sheer SQL to do this, right? If you were only to interact with the console of your database or anything similar, any application that connects to the database, what would you do to fetch the data that you need? You probably do not need the book, right? Because it won't be used at any point. Here, I'm fetching the books because I have the book IDs, right? But it's not really that I need the books. So quite some of that information is redundant. It is being fetched from the database, but to no avail. So what we could do is, okay, let's make everything fetched lazily. And then we can simply fetch all the reviews by the book ID, which I'm also omitting here, but you get the idea. I can simply write the query to fetch just the data that I need. I do not need to fetch the books just because I have the functionality to fetch by identity in Spring Data JPA. And what we get as a result is a single select to the database. Here I'm using a native query, but it could, as I said, it could as well be a JPQL query, criteria API, or declarative approach, whatever you're fancying using. This is just an example. And I would like you to notice one thing. Since ever I have started talking about JPA and Hibernate, so for 20 minutes now, this is the first time that Hibernate is fetching what we actually need. So the Hibernate is fetching just the right amount of data that we know. This is the first time since ever I have started talking about anything. So this is something to consider. But what I would like you to remember, or maybe let's put it in a different way. You might be thinking, okay, but we have those standards, right? Every to one is fetched eagerly, and every too many is fetched lazily. It must come from somewhere. Yes, it does, but it's not the optimal solution, right? If you take a look at Hibernate's documentation, their official recommendation is to actually fetch everything lazily and then at runtime specify the right amount of data that we need for the task at hand. This is the best way to control the data that we fetch from the database. We have the full control over it. Okay, let's move on to the next problem, which can be sometimes spotted. And this is manipulating element collection of embeddables. So the task that we are given here is that we have a book and we would like to filter out some of the awards by the name, right? So we are given a book ID and some pattern, and we would like to drop all the awards that match this pattern. How can we do this? Here's an example. Here's one approach. We can fetch the book using left join fetch, what we have learned in the previous example. This way we're fetching the book together with the awards. The field will be populated with the data. And then from the book, we're getting the awards. We're filtering it by our predicate, and then we're packing it back into a new list, setting it on awards and saving the new book. So the old book, but with the new collection of awards. And again, let's take a look what Hibernate does for us. The first query, the first SQL that is shot to the database is pretty intuitive. I would say even boring, because this is actually what we wrote, right? This is the exactly same thing that we have written here to fetch the book together with the awards. But then there is something slightly odd. As you can see, we have delete from award where book ID equals and some placeholder. So Hibernate actually drops everything that is associated with this book. You see, there is nothing related to this pattern. Hibernate doesn't know of the existence of any pattern or the IDs of the award, right? It just drops everything. And then we have a bunch of inserts that all look the same. So this is just the same insert that is repeated a couple of times. What's going on here? Again, let's take a look at our mapping. There are two main differences between how book is mapped and how award, how they are both represented. The first is that the book is an entity, right? While the award is an embeddable. The other thing is that the book is an abstract entity, so it has this ID. This is the requirement of an entity to have the ID field. The award doesn't have it because it doesn't need to. And so the embeddable usually is used to embed some columns in our model, but this time we're using it differently. But we do not need an ID. There is no such notion in Hibernate. So when we have a book together with a list of awards, and we pick one of the awards out, then Hibernate doesn't know which one we have removed. Or if we put one in, it doesn't know which one is the additional one. Or if any other modification happens. It is because if an award was an entity, it would compare the ID, right? And then it would know, okay, so this ID is removed. So I dropped the award with this ID. But since an award doesn't have a notion of identity for Hibernate cannot differentiate between the instances of the awards. So it uses the knowledge that it has as well as it can. So it simply drops everything and reinserts what is left in the collection, right? So this is what's happening here. There was some modification to the list of awards. We know we need to change it, but we don't know what happened. So what can we do? We just purge everything and then reinsert whatever is left. How can we approach this? As you might have already guessed by looking at the previous example, writing my own query would solve the problem, right? This is an example. Here I'm just dropping from the award all the rows that match the book ID and the name. This is the Postgres syntax that is similar to like, but this is the exactly same thing, but written in SQL as earlier. And this, since this is a native query, then Hibernate doesn't do anything to it, and it simply runs it as is on the database. So we have our result with a single query instead of 5 different ones. But you might say, okay, but we're not going to write a SQL query every time we need to do anything, right? To have the full control. I mean, what do we need this JPA and all the other abstractions for if we just write SQL ourselves? We would simply just get rid of it and get to basics. What can we do to enjoy the ease of use of JPA and Spring Data JPA and not be affected by those mistakes? Well, I would say the problem lies in mapping, because this is more of a workaround than the actual solution, because as I have already mentioned, this embeddable is rather used to embed some columns in our model, right? So this is not the perfect way to use an award as a collection that is somehow injected into yet another entity. Instead, if we know that we're going to modify them, if we are going to interact with the collection of those embeddables, they shouldn't be embeddables for us. They should be rather entities. We should rather give them the notion of identity, the entity annotation, and simply use bidirectional mapping, as we did in our previous example, to handle those cases. Yes, so the lesson I would like you to remember from this example is that embeddables are simply an extension to an entity. They do not have the identity on their own. So whenever we try to modify them, to interact with them in any way, we might stumble on some performance problems or other issues related to not having identity. So it is much simpler and much cleaner to use an entity in this way, right? The overhead is only one column more with an identity. All right, let's move on to the next one, which is invoking Flash on an entity manager inside a transaction. And let's start off with a simple example. We would like to update a grade of the review. So we have written a review, it's already in the database, but we would like to change the grade. And we have the ID of this review and the new grade. This is one approach that we can use. We fetch the review from the repository. And if it's there, then we just set the new grade on this review and save the review. But there is a small code smell in this snippet. Maybe you can spot it. And it's not about transactional, right? Because we want this to be transactional, this whole update business. There could be some additional logic in this method, like, I don't know, logging or checking for access if I'm authorized to change the grade and so on. Everything we would like to do should be done atomically, let's say. So this should be a single transaction. So this is not the case. There is something about those 4 lines or 5 lines that is a bit fishy. Maybe you can spot it. I will give you 10 seconds to think about this. The thing about this snippet is that it's equivalent to this one. And you see the difference is I have removed this save method called on the review repository. But the changes are there. The changes are reflected in the database. The grade is indeed edited. It is changed. So it does work. And if you're wondering why it happens, then you might be interested in this feature of Hibernate that is called dirty checking. So whenever we have a transactional context and we create a new entity, we can persist it, right? And then Hibernate tracks all the changes that are happening to this entity. So the new object is in the new state, in this state machine, right? Once we persist it, it becomes, well, Hibernate kind of becomes aware of this entity, and it tracks all the differences of the changes that happen to this instance. The same would happen if we persist something that we have removed or merge something that we have detached, and also if we fetch something from the database using find. What we used in our example was find by ID from JPA repository, which uses find under the hood. So what is returned is an entity that is managed by the persistence context, right? And once we exit the transaction, everything is flushed to the database. So all the changes that happen to all these entities that are in the persistence context are translated into SQL and then sent to the database. So this is what is happening in our case. Just as a side note, if you're wondering if changing one field would result in an update of just this field, no, this is not the case. So the entire object will be updated. Unfortunately, Hibernate does not track in that much of a detail. If you would like to make this dirty checking a bit more fine-grained, then you might be interested in using dynamic insert and dynamic update. This comes in handy in some cases, especially if we have really heavy objects and heavy tables. But to make this the idea of dirty checking a bit more concrete, maybe to understand it a bit better, let's consider yet another example. We would like to display all the messages of a receiver and mark them as read because we're displaying them. This is how we can approach this. So we are given an ID of the receiver and we're finding all the messages from the repository, right, by the receiver ID. And for every message, we are displaying it. Then we're setting the red flag to true. And then we're invoking save and flush. Let's see what happens. Sometimes we can see, well, at least I saw flush being used either as save and flush or entity manager flush in very weird places to overcome some, let's say, non-deterministic behavior of the persistence context. But this is rather very code small. Let's see what happens if we flush within a transaction. If we now take a look at the logs, this is no surprise. Let's see what Hibernate does. We can see, well, it doesn't surprise us, right? What we see in the logs. The first thing that we do is we're displaying the message, then we're setting the flag to true and pushing it to the database. So we are issuing this update on the database. And then we're going again with loop. We are displaying yet another message and then sending another request and so on and so on. And if we drop this end flash, or better yet, the entire line, because it's useless, it would be ignored anyway, then what we have is slightly different, right? Right now we have all the messages displayed, and then one, let's say, one block of updates, right? So what we are doing here is we're displaying a message and setting the flag to true. And then we're going on with our loop. We're displaying yet another one and changing another one. So we're going with our logic, and Hibernate keeps tracking all the changes. And then when we exit the method, the transaction is closed. But before we close the transaction, all the changes are translated into corresponding SQL queries and then run on the database. If everything succeeds, then we close the transaction and exit the method. So this is what we see here. And you might think, okay, but what's the difference really? Because in both cases, we have 3 updates, right? We have 3 updates here, 3 updates there. And the only thing that is, let's say, superfluous is this redundant one line, which is probably not a rare thing to see in any project, a redundant line of code. What's the difference here in terms of performance? And the magic here lies in the word batching. So let's again look in detail what is happening in this method. We are displaying the message, but then we need to go to the database, update the corresponding row, set all the fields there, and then go back and go on with our loop, right? And every time we are in the loop, we need to go to the database to make an update. Whereas here, we are going on with our logic, and then all the changes are packed into a single batch of SQL queries, of SQL statements, and as one sent to the database. So there's much less overhead. There's far less round trips to the database that we need to do if we do not flash inside the transaction. This is maybe not that apparent if we have 3 entities here, but if we have 10,000 of them, then yeah, this will become painful to wait for if we flash. So the conclusion here is that flashing is almost always a code smell and will likely lead to some performance issues later on. It might also hide some other flaws of our mapping or our solutions, so that it's not so visible to us when we test our application. And let's go to the last topic I would like to tackle, and this is using find to synchronize the relationship between entities. Okay, so what do I mean behind this big talk? Suppose that we would like to create a review for the book. Here again, I'm presenting two possible solutions. The first one uses Entity Manager. So what do? We have the book ID, the content, and the grade. So we can use the review builder, set the book, the comment, and the grade, build it, and then persist it. But wait, you remember that review does not have a book ID field. Instead, it has the book field, so of a type book, not long. So here, what we need to do is we have to somehow provide it with the book. So we use find to get the book by the ID. And the same thing happens here, right? We are fetching the book. If it's present, then we are setting it in our review together with the content and the grade, and then we are saving it with the review repository. This is the same thing, it's just written with those two technologies. And what Hibernate does is actually not surprising at all, because at first it fetches the book, which is what we are asking for, right? If we take a look at here of this 13th line, find book by ID, or here, find book ID, we are fetching the book. So this is nothing unexpected. And the second line is an insert to create a review, right? So this is also what we're doing with this save and persist. But again, I would like to ask you to consider what would you do if you were to again do the same thing using just SQL. Well, we have all the information we need, right? Well, let's suppose that ID is auto-generated, or we can use a sequence on the database, but the rest of the information is actually already given. We have the book ID, the grade, and the comment. We do not need to select the book. We wouldn't do that if we were in the DB console. We don't need that, right? Unless we want to make sure that the book exists. But probably the constraint exception would save us from messing up the data. Anyway, this first select is not really necessary. It is only because we need to supply Hibernate with the book, right? We need to somehow inform him that we need to make this review a child of a specific book that already exists in the database. But there is a way to do this using JPA, using Hibernate and Spring Data JPA, and this is by using getReference. So just looking at the first method from the previous slide, if we change find into getReference and the rest of this signature stays the same, apart from the name, it doesn't change at all, then what Hibernate does here is it creates a proxy that wraps over the ID of an entity of the type book. Quite like this proxy that was created for a field that was lazily fetched. Here, Hibernate doesn't go to the database to fetch the book because it's not needed. It simply is a carrier of the information about the identity of our entity, right? And the equivalent method is also exposed in JPA repository, and this is get1. Now, if we run our tests, we can see that indeed only a single insert is issued to the database. So we don't need to run any finds. We don't need to fetch anything from the database. If this ID, if the entity would be non-existent with this ID, so if we were to create a review for a non-existing book, then, as I said, the constraint exception would be thrown, and we would have to handle it somehow. So the thing to remember here is that find in any way, so either directly or indirectly by using find by ID or any other similar methods from JPA repository, should be used to fetch the data and not to synchronize the entities, because we do not need that data. As the name suggests, it should only be used if we need to fetch this data into our application. And to actually synchronize the relationships between the entities, we should rather opt for getReference from Entity Manager or get1 from JPA repository. Yes, and this was the last thing that I wanted to share with you. If you would like to come back to this presentation, then it will be available online under this link. Maybe you can use it as some kind of a guide, or maybe you can just go back to it if it was too information dense, let's say. And also, I have created a project from which the snippets were presented in this presentation, where I'm showcasing all these examples, all these problems, how to log them, and so on. If you'd like to play around with it or maybe find your own solutions, then you can go ahead and fetch it from GitHub and just play around. This is the bibliography that I was using for this presentation. And if you would like to know more about the performance side of JPA and Hibernate, then I highly recommend those two books. They're really good reads. And if you liked my presentation, then some time ago, actually it was quite a long time ago, I have given a presentation on Wrocław JAG, where I presented 7 JPA and SQL performance pitfalls that I have encountered when I was working with database access technologies. So if you find my presentation interesting and you would like to know more, you might also find the presentation under this link engaging. As you can see, the part about JPA might be overlapping in significant amounts, but the SQL part will be something new, something that I couldn't cover in this time frame. And thank you very much for your attention, and I hope you enjoyed it. I hope that you have learned something new, and I'd be glad to take on your questions. I will try to answer them as well as I can. Jeśli chodzi o wydajność, taką jak wysyłanie zapytań do milionów rekordów z bazy danych, co jest szybsze, Spring Data JPA czy JDBC? W ogóle uczyć się JDBC, czy lepiej od razu lecieć na frameworkach? So the question is, what if we handle millions of records on the database? Is it better to use abstractions like Spring Data or rather JDBC? Is it worth even learning those lower level libraries or frameworks, libraries rather, like JDBC, or rather aim for the higher level ones? So what I would say is they actually both can have the same result if you take control over it, right? So what I was showing you is a very fine-grained control over what Hibernate does. You don't always log everything that Hibernate does because there might be too much of it, right? Rather, if you have any performance-related issues with your application, if you need to somehow examine what's going on under the hood, you would probably debug the SQL queries that are created by Hibernate. Otherwise, what I would say is the aim for most projects is the developer productivity and not premature optimization. So I would say it's not that Spring Data JPA or JPA in general is bad and it will always cause performance issues. No, we can curate it so that it works just as fine as JDBC works. It's just sometimes we need to dig deeper and understand what's going on and know how to handle those cases. And if it's worth learning JDBC, probably it is worth to know something about how it works, at least have a general understanding. But those frameworks are there to ease our lives, right? To make our lives somewhat easier, somewhat more comfortable, right? Especially with the database access. So those are two different words, right? Relational database and object map model. We need to map those somehow. So those tools are really good tools. They really come in handy. Well, yeah, I know this is an answer in that depends style, but it really depends. I mean, if you're building a very high performance applications, then probably JDBC is the way to go to control everything. But other than that, I'd say most of applications can very successfully use higher level abstractions. Jak wykonywać złożone zapytania za pomocą Spring Boot i Hibernate? So, how to perform complex queries using Spring Boot and Hibernate? I'm not sure if I understand the question fully. How I understand is, well, you can answer yet another question if that doesn't answer it fully. How I understand this is that suppose you have a multi-line super complex query that I don't know, somehow runs this logic on the database mainly, and you just fetch the results or something like this, very huge query. Well, you can build your query in many ways. Here I have shown you using JPQL. So in versions of Java starting with 14 and above, if I remember correctly, you can have multi-line strings, so you can very nicely format them, and probably IDE will help you with everything. So you can write native queries or using JPQL or HQL, which is Hibernate specific query language. Or you can use programmatic ways like criteria API. You can look into it. This needs a bit of intuition on how to use it, but it is also a very nice and type safe way to do this. You can also do it declaratively. You can also try to split it into smaller parts. I mean, maybe running more than one query on the database won't kill you, and it will make your application easier to read, cleaner, and easier to maintain. There's one more library that I can recommend if you are writing a lot of SQL, which is Jooq. It's spelled Jooq. But I don't remember what it stands for. Well, essentially what it does, it takes the schema from your database, and out of it, it generates the code that will help you write queries in a type-safe manner. So this feels like writing SQL in Java with all the type safety, all the checking from the compiler, and so on. So this is also a very nice tool to have in your pocket. Thank you very much for your attention and for your questions, and I hope to see you someday soon on some conference, and have a nice evening.